Ever wonder why some materials can conduct electricity without any resistance at all? Well, let's dive into the enigmatic world of superconductors. Picture a world where electricity flows freely without any loss of energy. That's the magic of superconductors. They are materials that can conduct electric current with absolutely no resistance. Imagine you're sliding on a frictionless surface. You'd keep moving forever, right? That's exactly what happens with electricity in a superconductor. It can keep flowing indefinitely without losing any energy. But what makes superconductors so special? It's their defiance against the conventional laws of physics. Normally, all conductors resist electrical current to some extent, no matter how minimal. But superconductors, they laugh in the face of resistance. This phenomenon, known as superconductivity, is unique to these materials and is a topic of immense interest in the field of physics. Isn't it fascinating how superconductors have zero resistance to electrical current? Now you might ask, how does this happen? Well, let's dive into the world of superconductivity to understand this fascinating phenomenon. Superconductivity is like magic in the realm of physics. It's a state where certain materials, under the right conditions, can conduct electricity with zero resistance. Yes, you heard it right, zero. But how does a material transform into this magical state? Let's imagine a bustling city during rush hour. Cars are honking, people are rushing, and there's lots of resistance. Now, imagine the same city late at night when everyone's asleep. The streets are clear, and you can drive from one end to the other without any resistance. That's pretty much what happens with superconductivity. Most materials resist the flow of electric current to some extent. They're like the busy city during rush hour. But when the temperature drops drastically, it's as if the city goes to sleep. The electric current can then flow without any resistance, just like you can drive through the empty city streets. But why does temperature play such a crucial role? Well, normally the atoms in a material are in constant motion. They're like the people and cars in our city, creating resistance for the electric current. But when the temperature drops drastically, these atoms slow down, reducing the resistance to nearly zero. This is when a material turns into a superconductor. It's important to note that not all materials can become superconductors. Only certain materials have this special ability, and even they need to be cooled to extremely low temperatures, often close to absolute zero, which is minus 273.15 degrees Celsius. So, in a nutshell, superconductivity is a state where certain materials can conduct electricity with zero resistance, but only when they're cooled to extremely low temperatures. It's a fascinating phenomenon that still holds many mysteries for scientists to unravel. So, it's the drastic drop in temperature that brings about this remarkable change in materials, turning them into superconductors. But why should we care about superconductors? What's so special about them, you may wonder? Well, the significance of superconductors extends far beyond the realm of pure scientific curiosity. Imagine a world with ultra-efficient power grids devoid of energy loss, or maglev trains floating on invisible magnetic fields, providing frictionless and energy-efficient transportation. Picture MRI machines with enhanced imaging capabilities, enabling doctors to diagnose diseases with unprecedented accuracy. These are not mere fantasies, but the tangible applications of superconductors in our everyday lives. In the digital realm, superconductors are the key to quantum computers, which promise to outpace our fastest supercomputers by several orders of magnitude. They are also the backbone of ultra-sensitive detectors in telescopes, helping us unravel the mysteries of the universe. The magic of superconductors lies in their potential to transform our world. They are not just a scientific marvel, but a beacon of a future with limitless possibilities. Superconductors, with their incredible properties, are truly revolutionizing various sectors of our modern world. So, let's quickly recap what we've learned about superconductors. These remarkable materials have a unique property that sets them apart: zero electrical resistance. This means they can carry an electrical current indefinitely without losing any energy. But remember, this magical property is temperature dependent. Superconductors need to be cooled down to incredibly low temperatures to exhibit this behavior. Now, why are we so interested in these superconductors? Well, their zero resistance property opens up a whole new realm of possibilities. They're used in powerful magnets for MRI machines, in efficient power transmission lines, and even in quantum computers, pushing the boundaries of what we thought was possible. In the vast universe of physics, superconductors stand out as a fascinating phenomenon, showcasing the limitless possibilities of science and technology. As we continue to explore and understand them better, who knows what exciting new applications we might discover next?